Hi everyone and welcome back to Physics with Mr. Simons, where we simplify physics and get you exam ready. So today we're looking at Newton's laws again. We're looking at Limpopo 2014's exam paper. Limpopo is one of our provinces rich in platinum. And now we're looking at two bodies pulled with a constant force. Right, so basically where this applies in real life is where a truck is pulling a horse and trailer, or when one car is towing another car, etc. Right? We also use it when we are moving objects up and down in factories, production houses, etc. But yeah, let's look at the basics of this problem and hopefully you understand what I'm explaining to you. Feel free to leave a comment on how you feel I can improve this. Right? I need some critique so that I can make these lessons better. My objective is to truly help you master Newton's laws. Right, so question 2 of Limpopo 2014 says, diagram below shows a 3 kg block connected to a 1 kg block. So they connected there by a light inextensible string, and a constant horizontal force of 20 Newton pulls the system along a rough horizontal surface. Right? Now they say the frictional force between the blocks P and Q, the surface is 2 Newtons. So if we start from P, 2 newtons of friction and 1 newtons of friction. Number 1, state in words Newton's second law of motion. So normally the definition that we ask will be related to the problem that we're solving. 2.2, draw a labeled force diagram showing all forces acting on the 3 kg block. Calculate the magnitude of the acceleration. So Newton's second law and acceleration directly related. And then hence determine the magnitude of the tension in the string. We want the tension of the string between the 1 kg and the 3 kg, pardon. Alright, so as I say, pause the video here, see what you can answer, then come back as we work through the problems. Or work through the problems first and then come back and see what you understand and what you are able to solve. Especially these 3 questions here. Alright, so first problem or first definition. So state in words, I wrote state there. State in words Newton's second law of motion, right? So I know you can study definitions, but the key is understanding where we give them marks when we're marking. So number 1, we should know when a resultant force, or you can say net force, acts on an object, the object will accelerate in the direction of the resultant force. F net equal to mass times acceleration. But the key where we give this 2 marks is you stating that the acceleration is directly proportional to the net force, 1 mark, and inversely proportional to the mass, 2nd mark of the object. So get your 2 marks there. So although that's your 2 marks, you have to specify the top sentence, right? So all of that together will give you 2 marks. Now 2.2, they say draw a labeled force diagram showing all the forces acting on the 3 kg block. The frictional force between P and Q and the surface is 2 newtons and 1 newton respectively. So we have applied force moving to the right. Right? We have a frictional force moving to the left. But we also, as we're pulling here, that rope is pulling back against the 3 kg. So therefore we also have force of tension. So there for my 3 marks, you can see 1 for each force, right? So that is where we would get our 3 marks, right? So now we're going to have to use this in our problem so we are able to solve the problems given to us. Alright, so 2.3.1, calculate the magnitude of the acceleration of the 3 kg block, right? So we have the 3 kgs there. 1 kg, right? So if this object accelerating, I assume you know the 1 kg must also accelerate because they're attached by string, right? My applied force is 20 newtons, right? So frictional force was given as 2 newtons and 1 newton respectively. So we need to understand our forces in the x direction for both objects. We're going to have to solve this simultaneously because we have 2 bodies. So on the 3 kgs, I assume you know we have applied force, tension that's working against it, and friction. On a 1 kg, we have tension pulling it forward, but friction trying to stop it. Right, they said acceleration, so we're working with Newton's second law that says my resultant forces or my net forces equal mass times acceleration. For the 3 kg, same thing, my net forces equal mass times acceleration. So the 1 kg, my net forces in the x direction is just tension and 1 newtons. They are acting in opposite direction, so T minus F1 equal 1 times A. My mass is 1 kg. Right, F1 is 1 newtons, so there in the place of F1 I put 1, so T minus 1 equal 1A. If I take negative 1 across, it becomes tension equal 1A plus 1 for 1 Mach. If you look at the 3 kg, my net forces equal my mass times acceleration. Right, so we have my applied force minus the tension minus the friction must equal 3 times A. But my friction force or my frictional force is 2 newtons. So therefore F2 becomes 2. If I take T across, negative T becomes positive T. 20 minus 2 gives me 18. And if I take plus 3 across, it becomes minus 3. So now you can see I've created 2 equations, both making T the subject of the formula. This I can do because you see there, that rope is the same rope. It's not 2 different ropes. So the tension experienced by the 3 kg is the same tension experienced by the 1 kg. I hope that makes sense to you. Right, so therefore A plus 1 must equal 18 minus 3A because T and T is the same T. Right, now from there 18 minus 1 would give me 17. Minus 3 goes across, 18 plus 3A would give me 4A. 17 divided by 4 would give me 4,25 meters per second squared. So 1 mark there for creating my equation for 1 kg. Another mark for correct substitution, right? And then 1 mark for creating my equation for 3 kgs. Equating the two, another mark, so that gives me 4 marks. And then getting my final answer for acceleration, 5 marks. Right, so I hope you follow. This process is going to become very common. We're going to even do 2 bodies, upper incline. Right, that's another exam variation. They've tested a lot, especially in the prelim exams, like from now the 2021, 2022 going forward. All right. Now 2.3.2, they use the word hence, so meaning whatever I found there, I'm going to use this to solve here. Hence, determine the magnitude of the tension in the string, so I can use that tension equation or this tension equation. I went for the easier one. So there 1 times A, which is 4,25 plus 1. 4,25 plus 1 then gives me 5,25 newtons. So 1 mark for substitution and 1 mark for correct answer. Right, so very important. I hope you get used to this process. We're going to have to create these equations over and over as we're solving, whether it's 2 bodies, one on top of a table and one hanging down, whether it's 2 bodies pulled upper incline, etc. We're going to do a lot of simultaneous equations. Right, but I know you're smart enough to practice and master these things. We're going to work together. We're going to become successful together. I'm going to make sure I help you as far as I can. Right, God bless. I wish you nothing but the best. Bye.